Welcome to Electron Chemistry tutorial. I am Vijayalaxmi. Now, I will teach you based on the values of order. So, maybe order is 0, 0 order reactions, order is 1, first order reaction, order is 2, second order reaction, order is 3, third order reaction. Okay. So, I will teach you this type of reactions now. Okay. See here. So, what I am saying simply here. So, first of all, recollect definition of order. So, what is the order? Suppose for example, reactant gives rise to products. So, how to write rate law? Rate is equals to K into concentration of R. Power here may be N, active molecules N. So, this N is nothing but order of the reaction. Order of the reaction. Okay. The sum of the powers of the concentration terms of the reactants in rate law or rate equation is known as order of the reaction. Okay. So, this value may be positive, negative, fractional including 0. 1, 2, 3. Okay. So, more than 3 order is very rare. So, just 3. So, if order is 0, so they are called simply 0 order reactions. 0 order reactions. Okay. What I am saying here, suppose for example, reactant gives products. So, this instead of N may be 0. So, that is called simply 0 order reaction. Okay. What I am trying to say here. So, rate of the reaction, so write down again, R is equals to K into concentration of R power 0. Rate of the reaction is directly proportional to 0th power of the concentration term of the reactants. Is said to be 0 order reaction. 0 power nothing but, so this rate speed of the reaction not depends on this concentration of the reactants, or simply rate of the reaction, speed of the reaction independent on the concentration term of the reactant is said to be 0 order reaction. Okay. So, examples, some photochemical reactions. Photochemical reactions. Okay. And some catalyzed reactions. Photochemical reactions and some catalyzed reactions are 0 order reactions. I will show you with example. See here. Some photochemical reaction. Suppose H2 reacts with Cl2 in presence of light. So, that is nothing but a photo means light. So, then form 2 HCl. It follows 0 order reaction means R is equals to K into concentration H2 power 0, concentration Cl2 power 0. Okay. Now, see here. Next, suppose write down one catalyzed reaction. So, what is catalyzed reaction here? Write down. N2O decomposes to give N2 plus half O2 in the presence of hot platinum tube. Okay. So, then here also same what order is independent on the concentration of what N2O, laughing gas. Clear? So, this is what 0 order reaction. Now, go for, if order is 1, first order reaction. First order. Okay. Now, so how to define first order? Simply here R is equals to K into concentration of R power 1. Means how to define here? Rate of the reaction, it depends on the first power of the concentration term of the reactant. Is said to be first order reaction. Okay. So, simply example, decomposition of N2O5 will give N2O4 plus half HO2. Next decomposition of H2O2. H2O plus half O2. Okay, so these are first order reactions. Okay, now if order is 2, they are second order reactions. Second order reactions. How to define second order reaction? Simply R is equals to K into concentration of R power 2. Or maybe reactants, two types of reactants are there. So then simply here R is equals to K into concentration of A power 1, concentration of B power 1, 1 plus 1 is equals to 2. Order is equals to 2. Okay. Now how to define? Simply rate of the reaction is directly proportional to second power of the order of the second power of the concentration term of the reactant, or first power of the concentration terms of two reactants is said to be simply second order reaction. Okay, so write down example for second order reaction. Decomposition of NO2 gives rise to NO plus O2. So here R is equals to K into concentration of NO2 power 2. Okay. Now write down another example. Alkaline hydrolysis of ester. Any ester you can take here. CH3COO C2H5 NaOH. Simply it will give CH3COO Na. Okay, plus C2H5OH. Okay, so here R is equals to K into concentration of ester. So this is what ester, and alkaline. So 1 plus 1 is equals to 2. Okay, now third order reactions. Third order reactions. Simply here, maybe 3 moles of A gives rise to products. Then R is equals to K into concentration of what? A power 3. Okay. Or another possible, 2 moles of A, 1 mole of B gives rise to products. So here also order is equals to 3 here. Here also K A power 2 B power 1. N is equals to 2 plus 1 is equals to 3. Or another possible, A plus B plus C gives rise to products. R is equals to A power 1 B power 1 C power 1. How to define? Simply rate of the reaction is directly proportional to third power of the concentration term of the reactants. So write down example. Well known example, 2 moles of nitric oxide reacts with O2 gives 2 moles of NO2. So here R is equals to K into concentration of NO power 2, concentration of O2 power 1. So here 2 plus 1, third order reaction. Okay. Now pseudo first order reaction. Okay, listen to me carefully. If suppose for example A plus B gives rise to products, expected rate law R is equals to K into concentration of A, concentration of B. But the rate of the reaction depends on the only concentration of A but not on the B. Simply here order is what? 0, 1 plus 0 is equals to 1. But molecularity, how many molecules involved in that? 2. How to define? Simply, if the chemical reaction has molecularity is 2, order is 1, then the reaction is said to be pseudo first order reaction. Pseudo first order reaction. Okay. So write down example. Suppose for example hydrolysis of sucrose. Sucrose reacts with water molecules to give glucose and fructose. Glucose and fructose. Sucrose formula C12H22O11. Water formula we know very well H2O. Glucose formula C6H12O6. Then C6H12O6. Both are same but functional group is different. Okay. Now, so this reaction, sucrose is taken as 0.1 moles per liter. So here water taken as 10 moles per liter. So this hydrolysis takes place at infinity dilution. That's why 0.1 mole in 10 moles easily decomposes to give glucose and fructose. Okay. Now, initially, means reaction is not started, time is not started, time equals to 0. Then after some time, reaction is completed. Means initially concentration of sucrose, how much? 0.1 moles per liter. So water concentration 10 moles per liter. Okay. So initially there is no products because of reaction not to be started. After some time, here sucrose completely reacted to give products, so 0. So here 0.1 takes 0.1 only. So that's why after completing 0.1, remaining 9.9 moles per liter. 0.1 moles per liter of glucose is formed. 0.1 moles per liter of fructose is formed. Change in the concentration of water is almost negligible, because of 9.9 is approximately taken as 10 now. So that's why a rate of the reaction depends on the speed of the reaction depends on the concentration of sucrose only, but not on the water. Okay. So that's why here order is taken as 1 with respect to sucrose but not water. Clear? So that's why this is what? Pseudo first order reaction. Pseudo first order reaction. Clear? That's all. Thank you for watching this video. Did you like this video? Please like, share, subscribe my channel to get more videos.